In this lesson, we'll look at parallel and perpendicular lines. We'll compare their gradients and find equations of lines. Parallel lines have equal gradients. We can see that from the diagram there, where the gradient of the new line is still m, and the lines are parallel. If the gradient of the first line is m1 and the gradient of the second line is m2, then we can see that m1 equals m2. Perpendicular lines, on the other hand, are at right angles to one another. We use the square symbol to indicate that they're perpendicular. The gradient of the black line is m. The rise is m and the run is 1. When we rotate it through 90 degrees, the rise and the run swap places, and it's leaning in the opposite direction. It's a negative gradient now, so the gradient of that brown line then is negative 1 over m. When we multiply those two gradients together, we will get minus 1. And so if the product of two gradients is minus 1, we know that the two lines are perpendicular. In this example, we are asked to find the equation of a line that's perpendicular to this given line that passes through a given point. So the gradient of that given line is 3. We'll call that m1. And so the gradient of the perpendicular line, which we'll call m2, can be found by using the fact that the product of those two gradients has to be minus 1. So m1 is 3 times the second gradient that we're trying to find equals minus 1. So our second gradient is minus 1/3. And of course we can find that simply by getting the negative reciprocal of the given gradient there. So the equation of the perpendicular line will be of the form y equals minus 1/3 x, that's the gradient that we've just found out, plus some constant. And we still need to find that c. So we'll substitute x equals 6 and y equals 1 into that given equation. So there's x equals 6, y equals 1. Solving that now, we'll get minus 1/3 times 6 is minus 2, giving us c equals 3. So therefore our equation is y equals negative 1/3 x plus 3. The graph of the two lines is shown here. There's our original line and our perpendicular line. You can see they're at right angles to one another, and that the perpendicular line goes through the point 6, 1. In this example, we're asked if the two given lines are parallel or perpendicular. So to answer that, we need to find the gradients of the two lines. So the first line has a gradient of 5 over 2. To find the gradient of the second line, we need to rearrange the equation so that we have y as the subject. So let's put the minus 4y over the other side and the 3 over to that side, so that we'll get 4y equals 10x minus 3. We can divide by 4 throughout, and so we will get now a gradient of 10 over 4, which is equal to 5 over 2. So the second line has a gradient of 5 over 2, as does the first line. And so the gradients are equal, and so therefore the two lines are parallel. Let's have a look at two equations here in standard form. And you'll notice that the a and the b there have swapped places, and that we've taken the negative of the b there. And we're asked to show that those two lines are perpendicular. So we'll need to find the gradient of each of those two lines. So the gradient of the first line there is obtained by making y the subject. Dividing by b now, we'll get that, and so our gradient there is that minus a over b. Let's do the same with the second equation. We'll put the bx over the other side and then divide by a, and so our gradient here is b over a. Let's now multiply those two gradients together, and we'll see there that the b's cancel out and the a's cancel out to leave us with -1. Because their product is -1, then the lines are perpendicular. So we can see that to find a line that's perpendicular to a given line in this standard form, then we need to swap the a's and the b's around and change the sign of one of them. In this example, we're asked to find a line that's perpendicular to this given line that has a y-intercept of -2. And so what we need to do then is to find a line that's perpendicular firstly, and we can do that by swapping those x and y coefficients. That's a 1y there, so if we change them around, we can make that a 1x, and we'll make that a -3y. We need to change the sign of one of those coefficients, and we don't know what the d is yet, but we can find that using the fact that the y-intercept is -2. So we can substitute x equals 0 and y equals -2 into that equation to find d. Putting those values in, x is 0, y is -2, and so we'll get d is equal to 6, making our equation x minus 3y equals 6. In this lesson, we saw that if two lines are parallel, their gradients are equal. And if two lines are perpendicular, then the product of their gradients is equal to -1. So we can use that fact that if the product of two gradients is -1, then the lines are perpendicular.